On this example, we want to solve the exponential equation using the method of relating the bases. First, by rewriting the equation in the form b to the u equals b to the v. The equation that we're working with is 1 over the 5th root of 25 equals 5 to the x. I want to start off by writing the equation to have the same base on both sides. I'm looking at the value inside my radical, which is 25, and the value in the base on the right, which is 5. 25 can be written as 5 squared, and on the right we already have a base of 5, so I'm going to use 5 as my base. So I can write 25 as 5 squared, and I need to remember that radicals can be written as fractional powers. So because this is the 5th root, I can write this as 1 over 5 squared to the 1/5 power. I can simplify this using the power rule. The power rule for exponents allows me to multiply these powers together to get 1 over 5 to the 2/5 power. And then finally, because I have all of this in the denominator, I can use negative exponents to move this factor into the numerator. We would write this as 5 to the negative 2/5 equals 5 to the x. So I've written the equation to have the same base on both sides. And now I can use the method of relating the bases. The method of relating the bases states that if the bases are the same, then the exponents must be equal to each other. So I'm able to say that the exponent on the left is equal to the exponent on the right. And since this solves the equation, I'm able to stop here. I have the value of x to be negative 2/5. So the solution to the equation 1 over the 5th root of 25 equals 5 to the x is x equals negative 2/5. For this example, we want to solve the exponential equation using the method of relating the bases by first writing the equation in the form e to the u equals e to the v. We've seen relating the bases before, and this time they've changed the base to be e because that is the base that we see in our example. So our goal is to write it so that we have a base of e on the left and a base of e on the right. We can see that we have e on the left and e on the right. So we'll be able to use some exponential properties to simplify and write this with a base of e on both sides. On the left-hand side, we're able to use the properties of negative exponents to move this e to the 6x to the numerator. We can write that as e to the negative 6x. On the right-hand side, we have a radical. We need to keep in mind that the radicals can be written as fractional powers. This radical is a square root, and we would write that as e to the 1/2 power. In the denominator, there's no simplification needed at the moment. We'll leave that as e to the 2 minus x. On the right-hand side, we've got division with the same bases. So we're going to be able to use a property of exponents called the quotient rule. And the quotient rule deals with when you have a base to a power divided by that same base to a power. The quotient rule says that we would subtract the exponents to simplify. So that's what we'll do on the right. We have e to the negative 6x equals e to the 1/2 minus, we need to make sure we subtract the whole exponent, so I'm putting parentheses around that exponent. So this would give e to the negative 6x equals e to the 1/2 minus 2 plus x. I can now say that I've written both sides of the equation with the same base, and by the relating the bases method and the one-to-one property, these exponents must be equal to each other. So I can simplify the equation to be negative 6x equals 1/2 minus 2 plus x. So I have a linear equation. I'm going to start solving by getting rid of the fractions. So I'll multiply by 2 on the left and multiply by 2 on the right. This gives negative 12x equals 1 minus 4 plus 2x. So what I did is I used distributive property and the 2's canceled. I use the distributive property again. 2 times negative 2 is negative 4, and then 2 times x is x. I have negative 12x equals negative 3 plus 2x. I combined 1 and negative 4. I'm going to group the x's together, so I'll subtract 2x on both sides. That's negative 14x equals negative 3. And I'll divide both sides by negative 14 to get the x by itself. That reduces to 3/14. So the solution to 1 over e to the 6x equals square root of e over e to the 2 minus x is 3/14. For this example, we want to sketch the graph of an exponential function. F of x equals 1/8 to the x. I'm going to sketch the graph by plotting points. And I'm going to choose my standard set of x values, -2, -1, 0, 1, and 2. I'll substitute these in for x to find the y values. I'm going to start with the easier values. I have 1/8 to the first power is 1/8. 1/8 to the second power would be 1/64. 1/8 to the 0 power would be 1. 1/8 to the -1 power. Having a negative in the exponent means you're going to take the reciprocal of the base. So the reciprocal of 1/8 would be 8 over 1, and that's 8. 1/8 to the -2 power. Once again, that negative is reciprocal of the base, so we'll make that 8 over 1. 8 over 1 squared is 64. So this gives me a group of ordered pairs, and we'll plot those ordered pairs. I have 0, 1, 1 and an 8th, 2 and a 64th, -1 and 8, and -2 and 64 would be off my screen. This graph has a horizontal asymptote that is right on top of the x-axis. And that horizontal asymptote means that when I connect these points, the y values are going to get closer and closer and closer, but never reach that x-axis. On this side, my y is going to infinity. For this question, we want to solve the exponential equation using the method of relating the bases by first writing the equation in the form b to the u equals b to the v. We want to write the equation so that it has the same base on both sides so that we can apply this relating the bases method, or sometimes it's called the one-to-one property. The equation that we have for this example is 2 to the x minus 2 equals 1/4. On the left I have a base of 2, and on the right I have a base of 4. 4 can be written as 2 squared. So that's the base that I'm going to use to solve this, a base of 2. On the left I'll leave it the same to be 2 to the x minus 2. On the right, I'm going to change 4 to be 2 squared. And then I'm going to apply a property of negative exponents, which allows me to move this factor to the numerator. So this becomes 2 to the negative 2. And on the left, we're leaving it the same again. So now we've written it to have the same base on both sides of the equation. And by this relating the bases method, or the one-to-one property, it says that because the bases are the same, these exponents must be equal to each other. So that allows me to simplify this equation to be the exponent on the left of x minus 2 equal to the exponent on the right of negative 2. Then we're going to solve the equation that we have left. I'm going to add 2 to both sides, and this gives me x equals 0. So the solution to the equation 2 to the x minus 2 equals 1/4 is x equals 0. Thank you for checking out my videos. Have a great day.